Delve into art, architecture, and design with Srijan Design Academy SDA and thrive in exams, college, and career. Welcome to SDA. Figure-based aptitude. Topic 11. Surface development. Relevant for exams like NATA, JEE P2, NID, CEED, and UCEED.
Hello everyone. Today we are doing surface development. So what is this topic about? You will be given a 3D figure and you need to identify what is the 2D version of it. So when I say 2D version is basically when you unfold it, how the 2D will look like. So in this case, we have a 3D figure. Whenever you have a 3D figure, you need to identify two things. One is what is the top and bottom of it. And second, what are the lateral surfaces in that. So first of all, let me draw the figure. So once I have the figure with me, we can clearly understand that there exists a top surface and there exists a bottom surface. Now, other than this top and bottom, there are surfaces which are on the sides. So we either call them side surfaces or lateral surfaces, or we call them surrounding surfaces. So whatever you wish to call it. So we'll take it as side surfaces because that will be easier. So there is top, bottom, and side surfaces. Now, if I have to identify all the side surfaces, what I have to do? So all the side surfaces are something like this. So this is 1, this is 2. At the back, we'll have 3, and on this side, we'll have the 4th surface. So there will be 4 surfaces like this. So in all the examples, we can find all these 4 surfaces, but we want dotted lines in between. Why do we want dotted lines in between? Because dotted line means it is a folding. A continuous line means it is a cut. So if it has a cut, that means two surfaces are different. If it is dotted line, that means that surface, which means here, it is folding and therefore it is connected. So far, all these 4 surfaces are connected. Now, so this line is also busy. This line is also busy. Let me call it L1, let me call it L2, let me call it L3, and furthermore, we will have L4. All the 4 lines are now busy because they are connected to each other. Okay, so what will happen? We need to identify any other line. So that will either be connected to this side or this side or this side or that side in order to have a top flap. Similarly, it will be connected here, here, or somewhere to have a bottom surface. Now, so in which case we can find something like this? We can find something like this either in case of B or in case of D. Okay, why it is not in case of C? Because in case of C, both the lines are at the top. Okay, both the connection. So this connection is also at the top, this connection is also at the top. But we can't have that. We can have one connection at the top and we need to have one connection at the bottom. Now, what is the mistake in figure B? Figure B, there is a continuous line. So the moment we have a continuous line, what will happen? That surface is disconnected. That is not part of the overall development. So therefore, option D is correct. So in any figure, what is going to happen? First of all, we need to identify top surface, bottom surface, and the side surfaces. Now this top and bottom will keep changing. That we'll see in other figures. So we need to count number of side surfaces. Then we need to identify how side surfaces are connected to each other. And then we'll get the answer. So let's move to the next question. We'll have more clarification. Now, what is the top surface here? The top surface here looks something like this. Okay. Similar will be the bottom surface. That will also look like this. Now, with this line of the top surface, we'll get something like this. So that is all okay, which we can see in all the figures. With this line, we'll have something like this. Okay. And with the bigger line, we'll have something more bigger. So first of all, we need to find that L1 is already there. The surface related to L2 is there. Surface related to L3 should be bigger surface. So in which case we can find a bigger surface. So we can find bigger surface only in case of option B. Therefore, option B is correct. And then we can find a surface related to line 4 that is again equals to L2, a smaller surface. So that's how we are able to solve the problem. Now these surfaces can either be on one side or can be on another side. That's not a problem. The thing is we need to identify all the surfaces, and the thing is we need to identify them in correct order. So here we can find L1, then we can find surface related to L2, then we can find surface related to L3, and then we can find surface related to L4. Okay, it is in the same order. Yes, L1, then L2, then L3, and then L4. So that's correct. Let's move to another question. Now, what will happen if it's a round figure? If it's a round figure, we just need to identify what is top and bottom. So in this case, the top is a small circle, and then we have something like this, and the bottom is also a circle. but that is a bigger circle. Whenever there is a round surface, there won't be any cuts. It will be one single continuous surface. Why it will be one single continuous surface? Because there are no angles. When we make a cone or when we make a cylinder, you see that the paper is folding continuously. So we cannot find any angle. Okay. Either it's a continuous angle or there is no angle. So we consider it as no angle. And therefore, in surface development, it is considered as one single surface. So when we have one single surface, the option definitely that is going to be correct is A. Let's see here. Now, in this case, we don't have a top and bottom surface. But what do we have? We can call it front and back. That's fine. So therefore, these surfaces become our side surfaces. Okay. So first of all, we need to draw this figure and then we identify something. So when I draw this figure, I can name the lines. I can name the lines as L1, L2, and L3. Now L1 is the biggest line here. Then we get L3. Then we have something like L4, and then we have something like L5. Okay. Now, so L3 and L5 are again the bigger set of lines, and then L2. So first of all, we need to figure out whether surface connected to L1 exists or not. Okay. So yes, the surface connected to L exists in A, in B, and in C. Okay. D, why it's not there? Because the surface itself not there. Next, whether the surface connected to L2 is there or not, because that is the immediate surface. So it's there in only option A. It's not there in option B. It's not there in option C. Okay, you see this small surface here. So because this surface is missing, that's why we come to a conclusion that okay, these figures of surface development for a given 3D is wrong. Okay. In this case, we have to do a little more if the options B and C were correct. So what we have got in this case, a simple answer, because L2 wasn't existing, we got the answer in the first row itself. Okay, now let's move to this question. In this case, what happens? Now we can again call something as front and something as back. Okay, so what is a front and back? So when you have two surfaces which are almost equal or which are same, and other surfaces are acting as side surfaces. Okay, so basically you identify the side surfaces and then you come to the conclusion what is front and back or what is top and bottom. So that's how we figure out. Now let me draw the figure and then we'll do the same thing. Okay, so one by one. L1, L2, L3, L4, L5, 6, 7, 8, 9, and 10. So first of all, there are 10 surfaces. But one thing is you count all the 10 surfaces. Second thing is you can one by one identify all the surfaces. That is much easier. So we can find something is connected to L1 is there in all the figures. So second thing we'll do, we'll identify what is L2. Okay, L2 is also looking equal in everyone. So we are okay with this. Now let's go for L3 because L3 is a curved surface. So the length will not be this. Length will be equal to this much. Okay, it should be more than the straight line length. So in which case we can see this? In this case it is looking smaller. In this case it is looking little bit fine. In this case this is looking not fine. In this case this is fine. Okay, so we are getting two options, option B and D. Now let's identify the other surfaces. So we have identified L2, we have identified L3. Now let's go for L4. So in B and D, L4 is okay. L5 should be a bigger surface. That is also okay in both the cases. Now L6 should be on the other side, but we can't go to L6. So first of all, let's start going to L10. This one. Okay, so L10 is same. That's fine. Now 9, 8, 7 are equal. So 9, 8, 7 are equal. 9, 8, 7 are equal. But L6 is there in option B, but it's missing in option D. So this was the most complicated question we have faced so far, that we have to go for each and every surface, then only we were able to identify it. So because L6 is missing here, that's why option D is wrong and option B is correct. It has all the surfaces in the right order, in the right length. Okay. So number of surfaces are important, order is important, and their length is also important. So if you go in this order, you will be able to identify the answer for any surface development question whatsoever you face. Let's move to another question. What will happen now? So this is the front surface, that is the back surface. Okay, let's make a quick sketch to understand this. Okay, so this is the thing. we get L1 and L2. Now L1 and L2 are almost equal length. So first of all, let's just identify for L1 and L2 for the quick answer. So here this is connected. So okay, L1 is fine, L2 is fine. Okay, it's also fine here. It's not fine here. If L1 is here, L2 should be here. So that's why this option is wrong. This option is also correct. Now other surfaces, how many are these? 1, 2, 3, 4, 5, 6, 7, 8. So these are all in all 8 surfaces. So now we need to find 8 equal surfaces. In this case it is 7, in this case it is 7. Only here it is 8, therefore option A is correct. Once we know what are the details, once we know how to go about this question, we can easily find the answer within a minute or within some seconds. Now, here is another complicated question. You have an octahedron. That means 4 triangles at the top and 4 triangles at the bottom. Okay, so in such a figure, what we will do? First of all, let's identify a pyramid. Okay, so a pyramid looks something like this. What happens in a pyramid? The triangles are connected by a line. Okay, and they share a common point. So let's make a triangle. Okay, here is the common point. So they are connected by this. So they are connected by this. Here again they are connected, and here again they are connected. So we find the figure something like this. Why? Because they are connected by a single point at the top, and these are the connections. This is the connection. This is the connection where they are connected. So you will find one such figure, and then what happens for other figure? It is connected somewhere here. So it is connected at the bottom surface. So either it will be connected here, or it will be connected here, or it will be connected here, or it will be connected here. It can be connected to any surface. Okay, it doesn't matter which surface. So in this case, what happens? Option A looks correct because it is connected to almost this surface, and we have the similar figure at the bottom. So one will form a pyramid kind of shape at the top, another will form a pyramid kind of a shape at the bottom, and both will connect to each other. So that's the final answer for this question. Again, we have another question. So now it's a complicated one. What is the problem in this case? We can identify what are the side surfaces, but we can't identify what is the top and bottom. Okay, so we need to look at the answers and able to understand what things are there and what things are missing, and then only we will be able to answer this question. So if you look at the top surface, it has got U kind of a shape, which is this, and then we have a rectangle which has 3 surfaces connecting to it. Okay, and I told you in one other exercise when we were counting the surfaces that the back surface will become something like this. So this surface should be there out of a cube. So in this case, let's consider any example. Okay, so in this case, okay, we can find a shape something like this. So that looks pretty okay. Okay, that this is possible. Now let's just identify what options are similar to this. Okay, so in all the options, that is the similarity. Okay, what is changing? In this case, this is smaller, so that's why this is wrong. Okay, in this case, this flap, which is the front flap, this is missing, so therefore this is wrong. Okay, now 2 options are remaining, option A and B. So in option B, this part is looking smaller. This should be equally big because these are the side surfaces of a cube. Okay, so only in option A all the things are looking correct. So in a question where you have a lot of complication, what you need to do, you need to go to the options, identify what is missing in a particular question. So in a question which is more complicated, what you need to do, you need to go to the answer figures and identify what things are looking wrong. Once you identify what things are looking wrong, it is easier for you to answer the question rather than identifying the correct surface development, because that is very difficult in most of the figures. For easier figures, it can be easily done. For complicated figures, it becomes little difficult. So instead of going for identifying the real surface development, which may take a lot of time, you just go to the options and identify the correct patterns. Let's move to the next question. Okay, so all of you do the question by yourself and answer in the comments. We'll give you answer in next 5 days. And this is one more question for all of you. Do the question, answer in the comments. We'll keep posting you more questions. Thank you so much. Remain connected with us.
To buy our detailed study material online, WhatsApp us on 70420646648 or ping us on Instagram. For more questions, drop a comment on our video. Subscribe us to Thrive in Exams, College, and Career.